What we're going to show you now is some amazing technology made right here in America. In fact, right down the street from us here in California. You know, when you got old cars, a lot of time parts are not available. Now, this is a what do you call a D valve for a 1907 white steam car. What it does is it slides up and down and it allows steam to enter the piston. But what happened was it broke in half. Well, the last white steam dealer went out of business in 1910. And the chance of finding one of these is almost impossible. What you got to do is you're going to have to make one. And you go, well, how do you do that? Well, you could give it to a machinist, and he could spend, what do they make, a couple $100 an hour and play with it all day, and maybe they'd be close, maybe not. Or you could use this thing made by a company called Next Engine, scan it, and make yourself a new one. It's pretty amazing technology, and I think you'd be fascinated. And this is going to be a lifesaver if you have old cars. I want you to meet someone, Mark Knightley. Mark, come on in. How you doing?
Hi.
Now,
see you, Jay.
Explain to us what you do here, how this works.
Well, we have a machine over here, and it's called a three-dimensional scanner. And this three-dimensional scanner can measure about 1 million points on an object within a few minutes. So if you can compare it to the way things used to be done, you'd use a tool like this, a caliper, and if you wanted to measure, this is actually hard to measure with a caliper, but if I had a really simple part, like this little tube, I could just measure it in a few places. Right. And then I would know what I have, and I could make a model of it, or I could machine one up from that. When you have something that has a lot of curves in it, like this part, or this part, the curves flow into one another, and they're really complicated. So it's actually very difficult to make a model of this and reproduce it. So we're going to go ahead and take this part that Jay took off the steam engine, and Paul, if you can help us over here.
See, what we did was this split in half. Can you see the split there? It broke in half. What we've done is, for the sake of being able to make a new one, we've just sort of glued it back together. Obviously, this wouldn't work in a real-world application, but just so we can get the original size. I'm going to give it to Mark, and he's going to scan it.
So Paul's going to go over to this computer. That's a regular PC. And he's going to run this program over here. So he's going to go ahead and tell it to start. And we'll just do one little demo, and then I'll show you a finished model here in a second. These white lights are actually taking a photograph of the color of the object. See those red stripes that are on there, and see how they're swinging across? What they're doing is actually measuring the size and shape of the surface. They're doing about 50,000 points per second. And inside the computer, we have a model that looks something like what you see on the screen now, and we can swing it around. We've taken the physical part, you can stay with, and we've made a computer model. If you zoom in on that computer model, you can see it's made of tens of thousands of tiny little triangles. And that lets us, we can make a movie with it, we can do whatever, but what's of interest here is that we can then take that information and we can transfer it to other machines, like this printer over here made by Dimension. And this is a copy of the part that was made in ABS plastic. And from that, we can do castings, we can do all kinds of things.
It's almost as if you took the original part, put it in a Xerox machine, and made a three-dimensional copy. I mean, what this does, it'll make it out of plastic. So the advantage of it is we can then go see if it actually works, everything fits, then we can go and put it in our Fidel machine and make it, CNC machine, and make it out of metal. But it allows you to make a piece out of plastic, so you don't waste a lot of time making something, machining a part, and then, we're way off. With something like this, you can literally keep old cars on the road forever and ever, because you can make everything. That's the really cool thing about it. There's no mold or casting that you can't duplicate, especially on these small, hard-to-find parts.
So what's changed really recently is that this used to take a really big machine that cost $150,000 to do. And so now, with this little instrument, for less than $3,000, you can have in your own facility something that can make all these measurements. Yeah. Get you 1 million points on an object in a few minutes.
Yeah. And show how this printer works.
This is a really cool machine.
Yeah, this is like it's the Jetsons, all right?
This is like having a factory in your own place.
Yeah, it's pretty amazing. It's pretty, and this is what it uses, isn't it?
Yeah, these are filaments of plastic. They can be in polycarbonate or ABS, and it feeds it in like fishing line into a nozzle, and the nozzle has a very high temperature that can be turned on and off, and it actually moves it like a CNC machine. It moves the head around, and as it moves the head around, it deposits plastic wherever it is told by the computer program.
I mean, we stuck a wrench in there, and now we have a completely useless plastic wrench. But, I mean, it actually works. Look at that. I mean, it copies it exactly, and this moves in and out just like it would on the real wrench.
This is the magic thing about it, where the little wrench features that he was showing there, they were printed in place, assembled. And this machine actually has some supports. They're called soluble supports. They're made out of material that will dissolve in a special bath. And all the things that are delicately assembled can be temporarily held by these supports. And then when you wash them away, the parts actually work, already assembled. It's amazing.
It's pretty cool. And the thing I like about it is it's American technology. You know, I've kind of complained over the years that we needed some gears cut for a Duesenberg about 10 years ago. And I went to some gear cutters. I needed gears that were hypoid and helical. And every gear cutter was either out of business or sold their tooling to China or Korea, especially India. You had to send these Duesenberg parts to India to get them made. Here's an actual whole steam engine they made. See, you know the D valve I just showed you? There it is right there. See, it slides back and forward. The way a steam engine works is it slides here, lets steam in, pushes the piston down, D valve moves up, and goes back and forward like that.
This thing was made as a complete assembly. There was no assembly work afterward.
Yeah, that's pretty
because
amazing.
it's all made on one shot.
Yeah, pretty amazing. Now, do you guys have a website? How can they get in touch with you?
We do. It's called nextengine, all one word, .com. If you put in Google, if you put in 3D scanner, it'll come right up. So you can look for Next Engine or look for 3D scanner. And this machine here is made by Dimension. And if you go to the Dimension website, you can also go to the Stratasys website. You can learn all about this machine. And both of these products, by the way, they are, as Jay mentioned, they are American-made products. And I'm proud to say that both of these products are the #1 selling products in their categories in the world.
Yeah.
Both of them.
So I almost guarantee you, restoration shops, old English sports, whatever kind of car you're doing, or what kind of machines you're making, I think everybody will have these in the future, because let's face it, you're not going to, you know, a lot of the parts for the English cars now are being made in China, and they're poor quality. This way you can actually make them yourself. Find yourself a good machinist, make it in plastic, bring it to him. Pretty amazing.
And then you could see some samples over here of other things. We were talking about gears earlier. What a cool planetary setup this is. That was all printed on this machine.
Wow.
It's amazing.
I mean, how many old cars sit in the garage for lack of one part? And it'll sit there for the next 50 years because there's just no parts available. Well, that's not a problem anymore. Now you can make them yourself. Mark, thanks a lot.
Thank you
That's
so much,
really
Jay.
terrific.
Thank
Thanks.
you, Bernard.
Good. Thank you, Mark.
Pleasure.
Let's get that steam car running.